Hello everyone. Today we will look at Minterms Maxterms review, which I posted on Google Classroom. And we have the following. We're going to convert algebraic equations into Sum of Minterms, which are called canonical equations. We have three examples, 1, 2, and 3. And we also are going to convert algebraic form of Boolean expression into the product of Maxterms, which is another canonical form. And we have three examples. Okay, let's do it. Let's go back here, and our example number 1 is the following. We have a 4-variable function a plus b prime plus d times c prime. Okay, you're only allowed to do minterm expansion. For minterm expansion, in order to do it, you have to know the following. For minterm expansion, we're going to use yellow highlighted laws. A plus a prime is equal to 1. And first distributed law a plus b times c is distributed as follows. A times b plus a times c. Okay, let's look what we have here. So we have three terms, a, b prime, and c prime d. We have to expand it into a missing variable without altering the function. That means you cannot just add b to a. You have to, but you can multiply a times 1 in form of b plus b prime. That's what we're going to do in order to expand a into missing variables, because we want to expand this a into minterms, and minterms are products of all variables. So look at this. This is not a minterm, a, but this is a minterm, a prime, b prime, c prime, d. This is product of all variables. That's what we're aiming to do. Okay, so let's go from the top. A times b plus b prime, I'm expanding a, I'm expanding b prime into missing variable. So I'll start with a. B prime has also c and d missing, but we'll start with one variable at a time. So, and the c prime d right here, I'm expanding into a plus a prime. So a times b right here, a times b prime. So this a expands into ab plus ab prime. Now b prime expands into ab prime plus a prime b prime. ab prime plus a prime b prime. As you see, this ab prime and ab prime are identical terms, so we're going to cancel one term. We don't want to expand both of them into identical minterms. It doesn't make sense. Okay, so we have the following: c prime d right here. We're expanding in multiplying times a times c prime d, and a prime c prime d. Now let's look at this term, a and b. A times b. A times b is right here. We're expanding it further into c plus c prime. We're going to do the same thing with this. A b prime. We're going to expand it into missing c plus c prime. Now a prime b prime is expanded right here. A c prime d is expanded right here into missing variable b. A c prime c prime d is expanded right here into missing variable. So now let's go to line number 3, line number 4. Okay, so ABC right here plus ABC prime. So out of this term, we have two terms. Out of this term, expanded two terms. Out of this term, A prime B prime in parentheses C plus C prime. So out of this term, we have this two, A prime B prime C, A prime B prime C prime. Out of this term, we have this two, and we're expanding this term into this two. Now, right here, ABC, we're expanding this ABC with term D. So I'm going, instead of putting in parentheses ABC D plus D prime, I already expanded this ABC D plus ABC D prime. I did the same with this, the term ABC prime. ABC prime D plus d prime. Now a, b prime, c is right here. I added d and d prime to this term. So a, b prime, c, a, b prime, c have two variables added right here, d and d prime. And I did the same with this one. So just follow this. I expanded all the terms. These terms I don't have to expand because those are minterms already. As you see, there are all the variables are present in the term, in the product. So I didn't expand them, I just copied them. Okay, so now I'm going to, so we have the following. All those minterms are in terms of the product of all variables right here. Now I have to convert them into minterms with the subscript. Now let's start from the first one, ABCD. Which minterm is that? That's a good question. How do you do it? How do I know it's minterm 15? Because we're going to use binary method of finding out which minterm is there. Okay, so binary method calls for the following. If you have to have all variables in a minterms in alphabetical order. So it's ABCD, ABC prime D in this case. So once you have them all in alphabetical order, then you put the following. You put the 1 when the variable is unprimed. So if A is unprimed, B is unprimed, C is unprimed, and D as well, so you put 1, 1, 1, 1. And in binary, 1, 1, 1, 1 is 15. So that's how you create subscript 15. So lowercase m stands for minterms and 15. So this is how minterm 15 looks like. Let's look at what minterm is this. Unprimed variable, unprimed, and prime variable is minterm 14. It's 1, 1, 1, 0. That's 14. This stands for 8, 4, 2, and this is 1, which is 0. So it's 8, 4, and 2 is 14. That's minterm 14. This one is minterm 13 because of 1, 1, 0, and 1. So that's minterm 13. So we'll have my minterm 13. So I'm doing it with all my minterms right here. So this one is 1, 1, 0, 0, which is minterm 12 right here. Next one is minterm 11, 10, 9, 8, 3, 2, then is M1, M0, then minterm 13, 9, 13, 1. So all those terms were converted into minterms right here. As you see, we have a repeat minterms. The minterm 13 repeats itself 3 times. So we're crossing out minterm 13 twice, and we'll just leave minterm 13 one time. Okay, so those are called repeats, and you're going to eliminate it. Minterm 1 is also a repeat, it's right here. So minterm 1 is right here, it's a repeat, so you cross it out. So we have the following. All those minterms will be expressed in a canonical form as a sigma notation. Sigma in math stands for sum. That means you have to add all those minterms right here that follows the sigma sign. So sigma in parentheses, minterm 0 is present right here. Minterm 1, minterm 2, minterm 3, and then minterm 4, 5, and 6, and 7 I don't see it anywhere. That means that the minterm 4, 5, 6, and 7 are not present in this function. So, but minterm 8 all the way to minterm 15 is present. So instead of listing it from 8 to 15, I'm just going to use the little bit of shortcut and say 8 to 15. Okay, so I know this function can be expressed in canonical form as a sum of minterms 0, 1, 2, 3, and a all the way to 15. Okay, let's look at the next example. Next example is the following. X plus x prime y prime z plus x prime z prime. Okay, x has two variables missing. This term x has to be expanded into y and into z. So what I did, I multiplied x times 1 in form of y plus y prime, and z at the same time in form of z plus z prime. Now this term is already a min term. X prime, y prime, z is all three variables of this function. So we're leaving it alone. It's already min term. We don't have to convert it. But term x prime, z prime has one variable missing right here. So I'm expanding it into y plus y prime. And let's look what happens here. I'm multiplying this term, avoiding the both parentheses. So I'm going to have the following: x times y times z right here, x times y times z prime right here, x times y prime times z right here, and x times y prime times z prime. So out of this one term, I'm going to have 4 terms right here. Now this term is copied, x prime y prime z, and this term is expanded into this term. Okay, so check this if I did it correctly. Now, I have to organize them alphabetically in order to apply binary method of recognizing which minterm is this. Alright, so this one is alphabetically ordered, x, y, z. 1, 1, 1, because though all of them are unprimed, so it's minterm 7 right here. X, y, z prime, 1, 1, 0, minterm 6. X, y prime, z, 1, 0, 1, minterm 5. X, y prime, z prime, 1, 0, 0, minterm 4. That's it. This one is minterm 1, x prime, y prime, z. This one is not in alphabetical order. So in alphabetical order, it will be x prime, y, z prime. That will be 0, 1, 0. That's minterm 2 right here. This one will be x prime, y prime, z prime. If I order this alphabetically, that will be minterm 0 right here. So that means, do we have any repeats? 7, 6, 5, 4, 1, 2, 0. We have no repeats, so we don't cross anything out like we did here. So we're just going to put it in sigma notation, sum of all minterms ordered numerically. That means this function right here can be expressed in this form. So we have two forms of expressing the function. Why do we need this? Look at this function. This is algebraic expression. We're going to use this algebraic expression when we build a circuit using basic gates like AND gate, OR gate. You need this. You cannot build a function, you cannot build a circuit using this form because you don't know which gates to use. But if you use some more advanced microchips, you will not be able to use this. You have to use this format, this canonical format, okay? Because you have to send minterms or maxterms to the microprocessors, and you have to know which maxterms or minterms are in the function. Okay, so let's look at the next. This one. This one is four variable function, x prime plus z plus y prime. It is going to be very difficult to follow this method, to expand it into missing variable, because there's a lot of missing variables. In first term, a lot of missing variables. In second term, a lot of missing variables in the third term. Instead of it, we can go into maxterm expansion. We're going to expand it in maxterm wise. So function of x prime plus y prime plus z, I'm going to add 0. To this function, I'm going to add 0 in form of w times w prime. According to Boolean rules, we can do it because a times a prime is 0. That means variable times its prime is equal to 0. And I'm going to also use this distributive law for maximum expansion. Okay, so let's go back to our example. So this is how, so I'm adding 0. And this is how I'm going to break up this product. I'm going to take all these variables right here. I'm going to break up this product with all the terms, the entire term that stands in front of this product. Now let's look at here. This is how you do it. This is the term that stands in front of the product. And that's how it breaks up. A goes to first parenthesis, and breaks up B. B goes to first parenthesis, C goes to second parenthesis. So basically A plus B times A plus C, B and C are broken up. You see, they were together as a product, and they are broken up into separate parentheses. That's what we're doing it here. All right, so this term x prime plus y prime plus z goes into A, to first parenthesis, W, and x prime plus y prime plus z, which is my A, plus W prime, right here. So you see this term in parentheses and this term in parentheses are maxterms, because definition of maxterms is sum of all variables of the function. And you see we have the sum of all variables. We have 4 variables in the function, and there's a sum of all variables. Except they are not ordered alphabetically, so I'm going to put W in front right here, W prime in front right here. So this is it. W plus x prime plus y prime plus z. W prime plus x prime plus y prime plus z. Right here. Now, how do you recognize what maxterm is this? Is to apply binary method. Except when you have a variable that is not prime, you put 0 over it. When you have a variable that is prime, like x, now here, you put 1 over it. So W plus x prime plus y prime plus z is denoted in binary as 0, 1, 1, 0. So W prime, x prime, y prime, z will be denoted as 1, 1, 1, 0. So it's opposite to minterms. In minterms, when you have a unprime variable, you put 1 over it. In maxterms, when you have unprime variable, you put 0. Okay, so now let's look at this. 0, 1, 1, 0 is 6 in binary. So this is maxterm 6 times 1, 1, 1, 0 is maxterm 14. Okay, because 1, 1, 1, 0 in binary is 14. So we have a product of 2 maxterms, this maxterm and this maxterm. That means we're going to use the shorthand. It's a maxterm 6 times maxterm 14, and we're going to change it into canonical form. Because this is a product, we're using the pi notation from mathematics, which means product of the terms that follow pi. So the products of term 6 and term 14, right here, 6 and 14. This one is our maxterms. Now, we're looking for minterms. We're not looking for maxterms. We use maxterm expansion to find maxterms, but we have to answer what are the minterms. So that if you have a maxterm 6 and 14 in a function, that means you have minterms of 0, 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, 13, and 15 in the same function. So this function can be expressed as product of maxterm 6, 14, or sum of minterms. And as you see, subscripts are all subscripts that don't exist in maxterm. So if you have maxterm 6 and 14, you cannot have minterm 6 and 14. So as you see, 6 is missing from here, and 14 is missing from here. So this function is expressed in 3 different ways: algebraic, maxterm, product of maxterm, and sum of minterms. So we answered the question: what are the minterms of this function? Now, this is kind of illegal because we did maxterm expansions, which we were not allowed to do. So let's see if we can expand this function using the minterm expansion like this, except a little bit of the trick, shortcut trick or shortcut. Look what I did. I'm taking this function right here. If this function is x prime plus y prime plus z, x prime plus y prime plus z, then prime of this function is this. How do you create a prime or opposite of the function? So if the original function has x prime, prime of the function or inverse of the function has x. So I'm changing all the variables two opposites, x prime becomes x, y prime becomes y, z becomes z prime. And also I'm changing operators into their opposites. So plus becomes product, this plus becomes product, so or becomes and. So we have x prime plus y prime plus z becomes x times y times z prime. Now this one is very easy to explain. That's a Minterms. So this f prime is equal to x times y times z prime. I'm expanding it into missing variable, multiplying times 1 in form of w plus w prime. This is the expansion, and now I'm recognizing which minterm is this. W is here, x, y, z prime. So w, x, y, z prime is 1, 1, 1, 0. That's minterm 14. And this one is w prime, x, y, z prime. That's minterm 0, 1, 1, 0. Minterm 6. My f prime is minterm sum of minterm 6 and 14. That doesn't match this answer, because this answer is my function, and this is my function prime. So in order to revert function prime into function when you have minterms, you are going to do the following. If f prime is the sum of minterms 6 and 14, then f is the sum of those minterms. Okay, minterms that the rest of them. So f prime has minterm of 6, 14. F has a minterm every other minterm except 6 and 14. Right, and as you see, those two answers match. We did maximum expansion and got this answer. We got we primed the function and got the minterm and did the minterm expansion, and we got the same answer. Okay. All right. So let's look at how to do product of maxterms. Okay. So we have the following function: a plus b prime c prime. Now we're going to break up. So the first thing when you do maximum expansion is to break up all the products. So in this case we have one product. So we're going to break it up using distributive law, second distributive law. So a plus bc, and that's exactly what we have here. We have a term variable plus the product. So we're going to break it up: a plus b prime times a plus c prime. There we go. A plus b prime, a plus c prime. Now this is almost maxterm. There are two variables and function is three variables. So there's one variable missing right here in this parenthesis. So I'm going to add 0 in form of c times c prime. And I'm going to add 0 to the second parenthesis in form of b times b prime. So now I'm taking this term and breaking c plus c prime, which I introduced product into the first variable, first parenthesis. I have to break it up. So here we go. I'm taking this term, break up the c and c prime, sending c to this parenthesis and c prime to this parenthesis. And a plus b prime is copied right here and right here. I'm going to do exactly the same thing with this parenthesis. I'm taking this term and breaking b right here with b prime, sending to second parenthesis. And a plus c prime is right here. So now we have those four terms, those four parentheses, and they are maxterms. So we expanded this into those. The problem with those two is they are not in alphabetical order. So we're copying this, it's alphabetical order, copying this, we're putting C right here. And also C has to follow B. So we're going to do this. So I didn't change this. This is identical as this, except the terms are ordered. The variables are ordered. So now we're going to look what kind of a minterm is the parenthesis. So if you have a unprime variable, you put 0. If you have prime variable for maxterms, you put 1. Unprime variable, you put 0. So looks like you're creating a binary number 0, 1, 0. That's maxterm 2. Same here, 0, 1, 1. Maxterm 3. 0, 0, 1. Maxterm 1. And 0, 1, 1. Maxterm 3. A, B prime, C prime. Okay. So what we have here is, let's check this. So this one is max term 2, this one is max term 3, this is max term 2, max term 1. So this is max term 1, and this is A plus B prime plus C prime is max term 3. So looks like we have incorrect answer. So let's just max term 3. Okay. So let's put max term 3 here. Fix it up. Okay. So this is max term 3. All right. This looks like max term 3 is a repeat. So you cancel this max term 3, cancel one of the repeats, and we have the following answer. This function is product pi of maxims 1, 2, and 3. Maxims 1, 2, and 3. Okay. Now let's look at part B. Okay. This function wz plus xy. This is for variable function. This is for variable function. Now let's look at this. You have to break up all those products. That's the first, always first step. Break up the products into single variables. So you can either break up those products using distributive law, which would be very tedious for this particular example. So we're going to do a different way. We're going to take this function and prime it. That means if the function is wz plus xy, function prime will be opposite, w prime plus z prime times x prime plus y prime. So I change everything here. Wz is in parentheses because wz is the one term and it has to stay one term. Xy is also the term and it has to stay one term. So we will have to put parentheses over it. Okay, so now we have our products that are broken up. One simple step. Now we're going to expand this. We need two variables here and we need two variables here. So we're expanding this. This parenthesis, this term requires x. So we're adding x in form of, we're adding 0 in form of x times x prime. This requires w. So x prime plus y prime, as you see it here, I'm going to add 0 in form of w times w prime. Then I'm using distributive law to break up those terms. So we're going to have w prime z prime plus x, w prime plus z prime plus x, and w prime plus z prime plus x prime right here. So this parenthesis becomes this two. And this parenthesis right here becomes this two. Okay, and then we have 1, 2, 3, 4 parentheses. 4 parentheses, and each parenthesis has one variable missing. So we're going to expand this. This parenthesis is missing w. We expand it right here. This parenthesis, this term is missing w. This term is missing z, and this term is missing z. So we're going to add those in form of, add zeros in form of missing variables. And then we're going to break it up, right? So we're going to use all these three variables and break up y and y prime. So as you see, this right here, y goes here, y prime is here. So out of these 4 parentheses, we're creating it right here. And then we're going to order them, just so you have to check if this is correct. Just follow this on your own time. Now we're going to order them alphabetically. As you see, this is not alphabetically ordered. It's w should be in front of x. So we have to put w in front of x. So those 8 are alphabetically ordered. And now we're going to recognize which are these many terms. So w prime, x, y, z prime. W prime, you have to put 1 above it. X is unprime, so we put 0. And follow this logic. So it's 1, 0, 0, 1. 1, 0, 0, 1 is 9. Now let's look at this. 1, 0, 1, 1. That's 11. This is 8. This is 2. And this is 1. 8 to 1 is 11. So we have 11. Then this is 13. w prime, x prime, y prime, z prime. That's easy. That's 11. Okay, that's 15. Because 1, 1, 1, 1 is 15. So check if all those minterms, all those max terms are right. So we have max term 9, 11, 13, and so forth. 15 is a repeat. 15 was right here and was repeated here. So we're crossing out a repeat. And we express f prime as a product of the following max terms. That's not the answer. This is almost the answer, because we found what max terms exist in f prime. But the question is, what are the max terms of function f, not f prime? We develop f prime into its product of max terms. So we have to flip it into f. So if f prime is product of the following max terms, function f is a product of the rest of them. So look at this. F is the product of 0, 1, 2, 3, 4, 5. F prime has a maximum 6, so we cannot put it here. Maximum 7 we cannot put it here. So maximum 8 is missing from here. Maximum 10 is missing from here, so it goes to F. And maximum 12 is missing from F prime, so it goes to F. So if F prime is product of this maximum, F is product of this maximum. All right, let's look at the last question. It was not solved, so let's do it together. Okay, we have 4 variables, and we have a sum of 3 variables. It's almost a max term, right? Variable d is missing. So what do you think we should do? We should probably expand it into d, right? So we have the following: a plus b plus c plus 0 in the form of d times d prime. All right, so now we're going to take this product and break it up. Take this product, take this term and break up the product with the term that is in front of the product. Okay? All right, so let's look how it looks like. Okay, so now we have the following. We have 2 parentheses. When you break this according to distributive law, you're going to create 2 parentheses. So let's create it here. 1 parenthesis and 2 parentheses. So d and d prime will be broken into 2 separate parentheses with a plus b plus c prime. Okay, so it's a plus b plus c prime plus d. This is d, and a plus b plus c prime plus d prime. So that's this d prime goes here, this d goes here. Here we go. We created product of max terms. Max term is sum of all variables, and that's what we have. All right, so let's we have them organized in alphabetical order. So let's see if we can find what max term is this. This is non-primes, 0, 0. I'm applying binary method, 1, 0. Okay, and this is 0, 0, 1, 1. All right, looks good. So now we have the following. This is maxterm 2 and maxterm 3 looks like. It's maxterm 2 times maxterm 3. And that is equal to product of those 2 maxterms, 2 and 3. Here we go, big success. Okay, so we have this, and that will be our answer. So we concluded our review. Okay, thank you. And if you have any problems, just have to go through all of this video again and try to understand it. Okay, thank you.